All right, this is the video for Learning Target 5 notes. You'll notice that there's a lot of similarity between Learning Target 4 and 5. We're still factoring polynomials and solving them. It's just now that our polynomial equations could have irrational roots and even imaginary or complex roots. So it's going to involve some quadratic formula and square root property from old targets. And it's also going to involve two new formulas that we've yet to talk about from our factoring poster: the sum of two cubes and the difference of two cubes. All right, so first of all, let's look at something that's old that we've already done. Factoring, solved by factoring x squared minus 25. We didn't really look at it this way before, but I want to make sure you're seeing it this way for the sake of today. When we used the formula a squared minus b squared to factor x squared minus 25, x was our a and 5 was our b. So we could factor that to x minus 5, x plus 5, x minus 5 times x plus 5 is still equals 0. It's important that you keep this factored equal 0 because the zero product property would say if you're multiplying two things and you're getting an answer of 0, either x minus 5 is 0, so x is 5, add your 5 to both sides, or the x plus 5 is 0, and subtract your 5 and get the answer negative 5. Same thing with number 2. We would identify what you're squaring first and then use the formula to factor it. To get 4x squared, we would square 2x, and to get 49, we'd square 7. So it would factor to 2x minus 7 and 2x plus 7. So factors to 2x minus 7, 2x plus 7. And again, it's important that you remember it still equals 0, that we're factoring an equation. Because now the zero product property kicks in. It says either the 2x minus 7 equals 0 or the 2x plus 7 equals 0. We add our 7, we divide by 2, and we get the answer 7 over 2. In the second factor, we subtract 7, divide by 2, and get negative 7 over 2, which I've graphed in this original problem so we could see that had we done this in the calculator and hit second calc 0, left bound, right bound, so searched from, say, here to here, the calculator would have found the 0, negative 7 over 2 for us in the decimal form. Of course, if we had done the same over here, we'd have got x equals 3.5. The point being, this is learning target 4 we're reviewing. This same question could be in learning target 9 at the end of the unit, and it's going to be, instead of the directions being solved by factoring, it's just going to be solved. So anything will go. It's just that sometimes the calculator can't find the answers and algebra can. So we're going to look at a couple of new factoring techniques to solve some problems, and then we're going to revisit some old factoring techniques and solve some problems that the calculator can't. All right, so here we go. Number 1. I'm quoting from the factor poster. Step 1, x cubed minus 125. Does it have a GCF? And that's no. So then there's two terms to factor, and now there are two new formulas, sum and difference of two cubes, to consider. This is definitely subtraction, it's difference. Is it two perfect cubes? And the answer is yes. We would cube an x to get x cubed, and we would cube a 5 to get 125. So the x acts as the a, and the 5 acts as the b in the formula above. So when I go up here to the formula, difference of two cubes, x is our a, and 5 is our b. So according to this formula, it factors to x minus 5 times parentheses x squared plus x times 5 plus 5 squared. So I'll clean that up. The first parentheses says x minus 5. The second parentheses is a trinomial, and the first thing it says is square your a, so x squared. The middle says a times b, which was x times 5, or 5x. And the last thing says square your b. So square the 5, 25. That is the only new thing for today, using the formula difference of two cubes. The rest that we're going to cover today is all old material. So we'll use that factored version down here. X cubed minus 125 factors to x minus 5 times x squared plus 5x plus 25. And it's important to remember that this is still an equation. It still equals 0. So now the zero product property kicks in. It says either this binomial or this trinomial equals 0. That's the only way you get 0 when you multiply the two. So if it's the x minus 5 that equals 0, then x is 5. Easy. If it's the x squared plus 5x plus 25, you may think Lloyd, but it won't factor because there's nothing that multiplies to make 25 that adds to make 5. So how do we solve x squared plus 5x plus 25 equals 0? We got two choices. We can solve this since it doesn't factor. It won't be able to be solved. You can't solve it in the calculator. You either can factor by completing the square or you can use the quadratic formula. Given the two choices, I will use the quadratic formula every time. So remember, that is the opposite of b plus or minus some square root over 2 times a. Opposite of b is negative 5. 2 times a is 2. And the discriminant, just to remind you, this is something old. Make sure when you type in the discriminant, you type it in with parentheses. The discriminant is negative 75. All right, you may get bogged down in this part in the homework. You may remember or may not remember how to reduce the square root or the fraction or use the quadratic formula. If so, we can fix it in tutoring. But I'm going to go kind of quickly through this part because it is old material. The square root of negative 75 reduces, poke the I out, and then 75 is 25 times 3, so the square root of 25 becomes 5. So this becomes 5i square roots of 3. Neither fraction, negative 5 divided by 2 or 5i square roots of 3 divided by 2, reduces. So those are the final two answers. So our final answers, one of them is real and rational, and the other two are complex, for a total of 3 answers, and it was a degree 3. We've already picked up on this pattern. Degree 3s have 3 answers. Degree 2s have 2, and so forth. All right, so number 2. We're going to look at the graph real quick. If we graph x cubed plus 8, we will see that it crosses at x equals negative 2. So one of our solutions from an old technique is negative 2. And the twisting and turning, the max and min potential is happening above the x-axis, which means it'll never cross the x-axis again. So the other two answers we're looking for aren't real. So the only way to find them is going to be using what we're using today, or something we learn later. So first step, solve by factoring. Does it have a GCF? No. So then I begin. There's two terms. I begin to try to use the sum of 2 cubes formula. So I need to know, what am I cubing to make an x cubed, and what am I cubing to make an 8? And that would be x and 2. X is the A, 2 is the B. So up here, x cubed, 2 cubed, factors to x plus 2, x squared minus x times 2 plus 2 squared. Clean that up. That would say x plus 2 in the first parentheses, and then x squared minus 2x plus 4 in the second. Again, that's new, so you may have to pause the video, rewind it, hear that a couple times before it sinks in. But your A is x, your B is 2. That formula is literally plug in x for A, 2 for B, and reduce where needed. Okay, and really the only place needed is in the trinomial. All right, so it factors to x plus 2 times x squared minus 2x plus 4 equals 0. Zero product property kicks in, and either x plus 2 equals 0, so x is negative 2, the same answer we saw from the graph, or that quadratic won't factor, and it never will factor when you use the formulas, sum and difference of 2 cubed. When you use these formulas, it will never factor. The trinomial that you get will never factor. So go straight to the quadratic formula, or if you prefer, the solve by completing the square, which I wouldn't. But the quadratic formula would say opposite of b, 2 plus or minus some square root over 2 times a. The discriminant here, when you plug that in, you get negative 12. And that reduces to 2i square root of 3. And they're both divisible by 2. So 2 divided by 2 becomes 1, and 2i squared to 3 divided by 2 becomes I squared to 3. So your other two answers are imaginary. All right, I won't work number 3, but I will mention that to solve by factoring, it needs to equal 0. So your first step needs to be subtract 0, and there's no GCF. So it's got to be the new formula, difference of 2 cubes. Difference of 2 cubes, you would have x cubed, 3 cubed, and then you do this problem just like number 1. I mean, almost step for step. X is your A, 3 is your B. Okay? It actually is homework 16, so you can check it when you do that problem and look at the answer keys in class. All right, the last two, again, there's nothing new here. It's just using old things in a new way. Solve by factoring. There's no GCF. It's 3 terms, so your only choice is LOIF. Blank, 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 blank. Same thing with number 5. This is a kind of versus problem because they're so similar. There's no GCF in number 5. There's 3 terms, so your only choice is LOIF. The things that multiply to make x to the 4th are x squared and x squared. Same over here in number 5, x squared and x squared. The L, the negative 20, it's the same in both. So things that multiply to make negative 20, but in number 4, add to make 1. That'd be negative 4 and positive 5. In number 5, your middle term is negative x squared. So it's things that multiply to make negative 20, but add to make negative 1. That would be negative 5 and positive 4. All right, I'm fine if you stop there. As long as you've factored with one-step factoring and you have quadratic factors, you could then take the quadratic factor, use the zero product property, and solve x squared minus 4 equals 0. Personally, I wouldn't do that because that just jumps off the page at me that you can factor that one more time using the difference of 2 squares, 2x minus 2, x plus 2. So it's just intuitive that I will go ahead and factor it that way. And then x squared plus 5 won't factor any further, so I'll just rewrite that factor. X squared minus 5 over here in number 5, it won't factor any further, and neither will x squared plus 4, so we don't have a choice but to use the zero product property to finish these two problems. But back in number 4 over here, we could finish x minus 2 equals 0 to solve that and get x equals 2. X minus 2, when does that equal 0? When x is 2. And x squared plus 5, when does it equal 0? It's a similar question that we have to answer over here in number 5. So that's our decision. How do we finish these 3 little problems? You could use the quadratic formula, but the quickest way would be to use the square root property since there's not a middle term. And that would be subtract your 5 to both sides, x squared equals negative 5, and take the square root of both sides to get your 2 answers. X will equal plus or minus, poke the I out, I squared of 5. So again, you could use the quadratic formula, or you can use the square root property like we did there. So finishing this problem over here, add 5 to both sides, take the square root of both sides, and the square root property says plus or minus the square root of 5. Notice that's different than the 2 answers we got before. They're not imaginary. And then finally, the last, x squared plus 4 equals 0, subtract your 4. And then take the square root of both sides. And the square root property would say x equals plus or minus the square root of negative 4, 2i. All right, so to finish the problem up, to talk about, learning target 9 is what we're ultimately building towards. Had we started number 4 and graphed it in the calculator and hoped to find all the answers, the only 2 we would have found in the calculator would have been x equals 2 and, oh me, I got to fix that. That's probably been bothering you in the video for a while now. If that bothered you, I apologize. I made a mistake way back here when I said it just jumping off the page at me. So that's x minus 2 times x plus 2, x plus 2. So that answer should have been x equals negative 2. Sorry about that. If that confused you earlier, well, it probably should have confused you because I was going too fast. But yeah, when we graphed this problem, we would have seen it crossing at 2 and negative 2, but we would not have seen it crossing at I squared to 5 because those answers are imaginary. So to recap, if this is a learning target 9 question, and it very well could, you could get the first 2 answers out of the calculator, but you'd have to do something like factoring or something like what we just did to get the other 2. And in number 5, had you graphed it, you would have seen it crossing at square root of 5, which is x equals square root of 5. That's the decimal. Let's see, turn this on. Square root of 5 is like 2.236. If you did second calc left bound right, second calc 0, left bound right bound, you would have found the decimal equivalent, but the only way to get the exact answer would have been to do something like what we just did, okay? And these 2, of course, you wouldn't have seen where it was crossing either. But anyways, that's learning target 5. Very similar to 4. You'll just get some imaginary answers, some complex answers, and some square root answers using the quadratic formula, and every now and then the square root property, depending on how you choose to solve once you're using the zero product property.